that will be able to see this. If you can't see it, I'll try something else. This is the best I can do for right now. So let me get a bigger, thicker pen. Yeah, okay, y'all can read. Yeah, okay, all right. So I am so sorry about everything. I had gotten to that room 15 minutes early to get set up, and only to find out I couldn't have that room. And then I get into here and trying to set up a projector, and all I have is this cheap projector that I had in my office that doesn't project very well. And now for whatever reason, Microsoft is not letting me use any of its products. So I had to figure out, I normally use OneNote, and this is what I've got. So, all right, so because of all the time that I spent doing this, I'm gonna skip going over the first part, which are the definitions, although we might come back to those unless you see any of those words and you would like to know, just like, oh, yeah, I need to know what that one means because I've heard Rabelais say it and I didn't know what it was. Anything you see there? Okay, all right. On the first page of this handout, it reminds you of how to cast things into the phasor domain, and that's what you're going to be using in this for when you're doing AC circuits, as you'll be doing phasors. Okay, so we're going to start with just transforming some things to phasors, and by convention, we typically use cosine. There's no reason why we use cosine. You could use sine just as well, but since we're using cosine, we need to have everything in terms of cosine. So we're going to start by convert to phasor. And I have 10 sine 8t plus 75 degrees. So the first thing that I need to do is to change that to cosine. And to change it to cosine, I'm going to subtract 90 degrees from the phase angle. If it were in radians, you would subtract pi over 2. One thing that's really interesting, and I don't know why they do it. T, this part is in radians. That is radians, but this is degrees. So just in case you ever have to graph this, or there's anything going on, just be aware of that. So this is 10 sine 8t plus 75 minus 90 degrees, or 10 sine 8t minus 15 degrees. And we are going to keep things between plus and minus 180 degrees. So if you ever get something that is smaller than negative 180 or bigger than positive 180, just figure out what it would be, subtract 360 or add 360 to see what it would be. This should have been cosine when I changed that. And then to change this to a phasor, that means this is now 10 angle negative 15 degrees. It's not that the 8 is not important. The 8 is important. The 8 is our frequency. But we don't need the frequency to do these calculations. Hello? Oh, the elevator. How many of you got to try the elevator? I call it the Tower of Terror. There are stairs. There are two stairs, two sets of stairs, but they're kind of hidden. They're not like labeled stairs as far as I know.
It says exit.
Yeah, it says exit. Do you need a chair? It's probably...
Yeah, one right here.
Okay. So our next one, I have I2 of t is negative 17 cosine 9t minus 25 degrees. Now, there's nothing wrong with this as a trig function. As a trig function, it's just fine. I can have that negative number. But for phasors, the number represents our amplitude, and that needs to be a positive number. And so in order to make this into a positive number, we need to add 180 degrees to our phase, and then it will become positive. So this is the same as 17 cosine 9t minus 25 degrees plus 180 degrees, or 17 cosine 9t plus 155 degrees, or 17 angle 155 degrees. If you are using a TI-84 calculator, this would be, you do these as their exponential forms, which would be 17e to the j1, except it needs to be in radians, so 155 times pi over 180. You do have to turn it into radians if you're using a TI-84. Okay, and then our last one, I have 8 cosine 6t minus 45 degrees minus 5 sine 6t. Yeah, they're all gone. I'm going to head to my office in a minute to get the cookies that I promised. And when I do that, I can print out another copy. Does anybody else want a copy while I'm there? Okay.
It's on Moodle, right?
Yeah, it is on Moodle, so it is, yeah.
Is this going to be recorded?
I am recording it. I have severe doubts about anything working today. Just nothing seems to have worked today, but right now I am recording it, so I am planning to post it. But I just at this point, I'm not, with everything that's gone wrong today, I'm not counting on it working. But that's my plan, yeah.
Whenever you were talking about, like, you gotta make the negative a positive.
Yes.
Are you talking about the negative in front of the 17 or the negative in front of the 25?
The negative in front of 17, why? Did I change it?
No.
Yes. No, it's the negative in front. You have to have a positive amplitude in front.
So, I'm supposed to be in the financial
Right. Right.
So you're going to record it?
I am going to record it and post it.
Are you going to email it to us? Or?
No, it's going to be posted in the, I probably will email as well, just for this first time, but it'll be posted in your Moodle under SI resources.
Thank you so much. So I'm good to do it.
So yeah, you're good to go.
Awesome.
Yes.
Thank you.
Okay, so I can't directly combine the sine and cosine, and so I need to get these to be all the same in some way or another. So what I can do is say that this one is 8 angle negative no, it's not. Yeah, that's angle negative 45. And this one would be minus 5 cosine 6t minus 90 degrees. So that would be minus 5 well, but then I need to add 180 to make it positive on the outside. So plus 5 cosine 6t plus 90 degrees. And then that makes this 5 angle 90 degrees. But 90 degrees, this is our real axis, this is our imaginary axis. 90 degrees is just right there. So angle 90 degrees is the same as 5J. J is the imaginary unit, so J is the same as I that you learned in high school. This is the same. If I wanted to change this to I and J components, this is the same as 8 it's negative 45 degrees, so that's down there. So 8 times the cosine and sine of 45 are both square root of 2 over 2. In the real direction, so it's, and then minus 8 times the square root of 2 over 2 in the imaginary direction. So I just want to think of this as a vector. So that's the real axis, that's the imaginary axis. And I believe 8 times the square root of 2 over 2 is 5.67. So that's 5.67 minus J 5.67 plus J5, which is 5.67 minus J 0.67. And then do y'all know how to change back from A plus B, JB to phasor form? I'll show you. So I have 5.67 minus J 0.67. Now to get that as a phasor, the magnitude is going to be 5.67 squared plus negative 0.67 squared. So you just use the Pythagorean theorem. And when you do that, you get 5.7. And the angle is going to be the inverse tangent of negative 0.67 over 5.67. And if you take that angle, you get a negative 6.62 degrees. And if you do this by hand, which I never do it by hand because this calculator that I recommend does all of this for you. You don't have to ever do this by hand except for maybe on the first quiz. And if you've already had that first quiz, if he did make you do it by hand, you won't ever have to do this by hand again. But if you do it by hand, you have to realize that when you take the inverse tangent, it's only going to give you this angle right here. It also could have been this angle here in the second quadrant, in which case you'd have to add 180 to it. And so you just have to pay attention to where your imaginary number actually was. But you won't have to do that because so this was 5.7 angle negative 6.62. On this calculator, I can do 5.67 minus I 0.67, And then I can go to my complex menu and I can say change to R comma R theta, and it gives it to me in R theta, except I'm in radians. I need to be in degrees. And there it gets me the right answer. So you really, if you don't have a calculator that does this easily, you would need to get one. Okay, so any question? Oh, I was gonna pause for a minute. I'm gonna go print out some more. How many people wanted one? And I'll be right back. And yes.
I'm your sheet, but going back to like this second to last.
This or the page before this? Did you have a question, or did you just need to copy? Okay, and if anybody else needs something while I'm gone, feel free to just like scroll around and is that just one copy they have?
What? Is that a plus? Is that a plus? Between the 8? Between the 8?
That's a minus because when it's below the x-axis, your imaginary part is negative. So please eat cookies because I don't need to have them just stick something past them.
Let's go.
Yes, and these are going to be prizes, but I feel like you all deserve prizes for being here. So also help yourself to this delicious, good Halloween candy. This is not the bad stuff. This is the good stuff. So take 2 or 3 of them.
How long is
It ordinarily will go until close to 5. This time it's going to go like probably till quarter to 5. 4:45. Probably. What's that? Usually I'll be able to stay until 5, but today I probably have to end at like 4:45. And I realized I couldn't print because my computer was in here. And I don't know if I can open the document because it's in Word, and Word happens to be Microsoft.
I'd like to see if my dad's going to test me about eating dinner.
It has the cutest little Twizzlers in the Halloween candy. It's like little baby Twizzlers. Oh, by the way, make sure you don't leave any mess in here because this is really not my room. This is where you might be doing a capstone project. This is where the seniors, this is their space to work on their projects. And so I still their space.
Depends on where you're going to. That's what I think.
Now, ordinarily, I pause the recording when I do something like step out of the room and I start and stop after each problem, so I can just post each problem individually, so you don't have to like go through the entire video to find the one you want. But with the way things are going today, I didn't want to take any chances, and I'm just leaving it recorded. So there's just going to be one long recording. So that's what we got. All right. Let's do the next problem.
Oh, I got there in line. Probably one.
Now, you do always need to pay attention to your units, and so the units here are given as milliamps, and so even though it's like as an equation, that is going to be important. And then we've got a circuit. And R and C, so R is 20 ohms and C is 1 microfarad. Okay, so we are going to find IC using phasors. And the first thing we need to do is cast everything into the phasor domain. And so when you look at the equation that we have up there, the 12 and the minus 60 gives us the amplitude and phase of our current. So our current is 12 angle minus 60. Now, it also gives us omega, and we need omega because for a capacitor in the phasor domain, the capacitor is minus J over omega C. And omega is the coefficient of T. So omega is 2 pi times 10 to the negative fourth. Now you want to be careful. If they give you, this is the angular frequency. If they give you the frequency, that would be in hertz. Angular frequency is in radians per second. If they give you the frequency, you need omega here. That's the thing that looks like a W, but it's the Greek lowercase omega. And omega equals 2 pi f. So if you're ever given 60 hertz or something like that, that's how you get omega. So omega is 2 pi f. And so in the phasor domain, our capacitor is minus J over 2 pi times 10 to the negative 4 times 12, no, what did I say C was? 1 times 10 to the negative 6. And
Omega's the positive 4. Into the positive 4.
it is to the positive 4. Did I think so. Is it, yes, it is to the positive 4. Yes, thank you.
Is that NET at the bottom? Is that like distribution?
Say it again.
Is that NET? Past the minus 60?
That's I was about to draw a current source. This was 12 angle negative 60. And then I was about to read, that was the current source. was about to redraw the circuit.
What?
This?
Oh, no, that's milliamps. Okay, so now I'll redraw the circuit. It is positive 4. And this is 12 angle negative 60. And R is 20. And try. No, I can't. I can. And this is, this is a capacitor. So the capacitor, it's minus J over 2 pi times 10 to the negative 2. So let's figure out what that is. One over 2 pi times 10 to the negative 2, 15.92. Minus J 15.92. Okay, so now I've cast everything into the phasor domain, and I want to get the current going down this branch. So I can just use current division. So if you remember the way current division works, if I have a current and it goes into 2 resistors, RA and RB, and I have IA and IB, and my current coming in is I, then IA equals my total current times the other resistor over the sum of the 2 resistors, and IB I can either say IB equals I minus IA, or I can say it is the total current. Oh, yeah, that's screen's not writing. Total current times the other resistor over the sum of the 2 resistors. So, and I can do the same thing even with complex numbers. Oh, I see, you can't see it. That's just a review of current division. And so the current through our capacitor will be our total current, which was, what was it? 12 angle minus 60 times the other resistor, which was 30, was it 30? 20? Over 20 minus, and what was my value, J? $15.92. Okay, now if you had to do this by hand, it's always a pain, but we don't have to do it by hand. So now I can do 12 And then I go to my complex number menu, and I get angle -60. I'll put that in parentheses to be safe. What's that? Yes. Oh, the complex menu is second in the button that says pi EI. Times, and then I'll have my fraction, and what did I have? I had 20 over 20 minus I 15 point, what was it? 92. And it's going to give me the answer in A plus JB form. So 8.7 minus J 3.4. (8.7 minus J 3.44). And that's going to be milliamps. Or if I want to change that back to phasor, I go to second and my complex number menu and change to R angle theta, and I get 9.38 angle -21.5. And then, if I have to put my answer back in the time domain, this means that it's going to be (9.4) cosine, and then the frequency doesn't change. That's still going to be 2 pi times 10 to the 4t minus, that was supposed to be a 21.5. minus 21.5 degrees. You do need to put the degree symbol on there to be 100% accurate, just so that, you know, without a degree symbol it means radians. I don't think anybody would take off for that, but just in case. Rectangular, yes? You said can you, or how do you?
Well, that's rectangular.
This is time domain. This is rectangular, and this is phasor. And I do need to put milliamps after it. Okay, any questions? Do I need to start the cookies going around again? Yes. If you would be so kind after you take ones, you're going to skip. Okay, so on our next problem, we're supposed to find the voltage, and we're given this circuit that we have an inductor and a resistor in series, and they're both in parallel. I'm sorry, an inductor and a capacitor in series, and they're both in parallel with the resistor. And we are supposed to find the voltage across either one of those, it doesn't matter. What I am going to do is I'm going to do a source transformation because I don't think y'all did source transformations in circuits 1. Is that correct? But okay, but people will expect that you know how to do them, so I'm going to show you how. So, and because what a source transformation does, so a source transformation takes current source plus resistor in parallel to a voltage source plus resistor in series. And all of the things that work like not in phasor domain work in phasor domain as well. So, you know, anything that you could do before, mesh analysis, nodal analysis, all of that stuff works. So source transformation works. So if I have this, which you can't see, if I have this, I can convert it to a voltage source and a resistor in series. And the rule is easy to remember. R stays the same and V equals IR. So if I'm going from a current source and resistor to a voltage source and resistor, then the R is the same and this V equals IR. But if I'm going the other way, the R is the same and I equals V over R. Okay, so we had our current source was 35 sine 300t minus 15 degrees. As a phasor, that will be 35 angle negative 105 degrees because I needed to change it to cosine. So that was my current source, and so my voltage will be 35 angle negative 105 degrees times my resistor, which was 80. Resistors are always real and they only have a real part. And so 80 times 35 angle negative 105 is do I have an extra zero there? No, that's right. Um, except that was milliamps, right? And so times 10 to the negative third because it was milliamps. So 3.6 angle negative 105 degrees. Now the plus of my voltage source goes in the same direction as my arrow was. Did I make a mistake? Oh, I cannot add, I think I can, but I can't. Even though I know that I can't. I cannot add, subtract, multiply, divide. Those are mistakes I will make. So if you think I've made one of them, I probably have. Oh, okay.
You said 25, is that 35 times, wait, 35 angle,
35 angle 105 times 80.
gotcha. And it says 3600 angle 105.
Angle negative 105 degrees.
So what happened to the 300T?
That is just kind of hanging out on the side saying, you do the whole problem, and then if you need me, I'm here. I'm the frequency. This was 80 ohms. Okay, and our resistor is J omega L. Oh, and so now we need it. So now we're like, hey, well, what's omega? That's 300T. Omega is 300. So this is J times 300 times 15 times 10 to the negative 3 because it was millihenries. Can someone do 300 times 15 times 10 to the negative 3? Let's see, that'd be I think it's 4.5 or 45. 0.45. J 4.5. So this is J 4.5. And our capacitor was 200 microfarads. So our capacitor is minus J over C omega C. And that's minus J over 300 times 200 times 10 to the minus 6. So that's, I'm going to write it here where you can't see, 60000 times 10 to the minus 6.06. That's minus J over 0.06. And can someone tell me what 1 over 0.06 is? Nobody has a calculator out?
16.667.
Say it again.
16.667.
So minus 16.67 J. I sometimes, the J, engineers put the J in front, mathematicians put the I at the back of the number, and I go back and forth. And so you'll see me sometimes put the J in front and sometimes at the end of the number. It doesn't really make any difference, but okay, so I want the voltage across this, and so I'm going to do voltage division. And voltage division is like current division, but with current division, you take the value of the other resistance. For voltage division, you take the value of the resistance that you want to find, or here it's impedance, the impedance that you want to find the voltage over. So, it should have been 45, not 4.5. So for voltage division, I'll take my total voltage, which is 3.6 angle negative 105, times these two are in series, so I can just add them together. So 45 minus 16.7 is 12.17. So J, that'll be in the denominator, no, it'll be in the numerator, J 12.17. And then in the denominator will be J 12.17 plus 80. So I added these together to get J 12.17. My 3.6 is not correct. What's that?
I think you're right the first time. You should be 4.5. Is that a method?
I'm looking at what the answer is supposed to be. So let me see. Thank you. See, I told you I can't. This was supposed to be 2,800, which makes this 2.8. Which makes this 2.8. Which makes this 2.8. And you think the 4.5, I did something wrong there?
Well, I mean, you said it was 300 times 50 times 10 to the negative 3.
Yeah, that's what I said.
Yeah, I think it's supposed to be 4.5. Yeah.
Ah, so that means that's where this comes from. This is really negative 12.17. A negative 16.7 because I was just copying the answer. So this is J 4.5, and a positive 4.5 and a negative 16.7 is a negative J 12.17. Okay, so now we have all the correct numbers. So now 2.8 angle, what was my angle? Negative 105 times negative J 12.17 over negative J 12.17 12.17 plus 80 and I get negative 0.412 something plus something. I'm going to change that to phasor. And I get 0.42 angle 173. And that was volts.
How did you get 173? You got in 3 seconds.
Oh, I let the calculator do it. So at this point, so what if I had to do it by hand? I'd have to change both of these to phasors. So this top one would be 12.17 angle negative 90, because J is negative 90. And then I'd have to figure out what this one was. And then I would subtract them. And then I think you actually would get, if you did this by hand, I think you would get, I'm not sure what you would get. I mean, you should get the same answer.
So like just, we would just plug it in the way that you did if we didn't have to.
Yeah, I'll show you. Hold on. Except I think, did I type this in wrong? .8 angle negative 105 times negative J 12.17 over negative J 12.17 plus 80. They got something different than I did. I don't know why.
It's supposed to be in the degrees, right?
Yeah.
And why do you have to add the 80
Why? Oh, because I was doing voltage division. So I was saying so what I was doing was I had a voltage source over here and I had two resistors here. So I have RA and RB. And I wanted the voltage across RB. And the voltage across RB is V times RB over RB plus RA. And that should have been a negative right there. Okay, I have to stop here, and I apologize. I'm not normally organized, but I'm normally much better than this. This is extreme, and usually we'll be in the room over there unless they've come and taken it away, and then I don't know what I'll do. But I do have to get going because I'm supposed to be somewhere very shortly. Thank you so much for coming. I really appreciate it. I really do. It makes it worth doing if knowing that people are going to come. So thank you. Oh well, I love doing it.
Are you going to post the solutions?
I'm going to post the video. I don't post the solutions usually unless I make a mistake, but I'll post the video.